Hi everyone, I am Mallikarjun. Now I discussing about neo4j tool. neo4j tool for introduction, features and some of the characteristics. neo4j tool it solves some graph problems in software backend system. neo4j tool contain introduction, how to install and run, executing query, examples and application. neo4j tool. First on introduction. What is neo4j? neo4j is a robust, scalable native graph database developed by Neo Technology. Hence, name is neo4j. It is the most widely used graph database in the world. neo4j is almost all 54% is used in the world. So, it is the largest used graph database in the world. The neo4j graph database includes its own graph query language called CIPHER. A developer workbench environment and basic visualization tool known as neo4j browser. Some important characteristics of neo4j. A graph database plus Lucene index. A graph database means it has a graph, nodes, links and relationships. Plus Lucene index. Lucene index is a searching a target node by using particular index. Hence, it's called Lucene index. Property graph. A property graph is a graph which contains all components like nodes, links, or relations, or how they are related to each other. It's about powerful acid. Full acid means atomicity, consistency, isolation, and durability. It has high availability in nature. It supports for embedded server and it uses API called REST. What is a graph database? An abstract representation of set of objects where some pairs are connected by links. Usually pairs are nodes and links are edges. So nodes are connected by edges with relations called graph database. A graph database is a type of NoSQL data store that has been optimized for highly connected data. Here, NoSQL data is a backend storage of graph database. It is storing and querying data in a graph format, that is, as a collection of objects and relationship usually called nodes and edges. Example of NoSQL word and uses and complexity. Here, a graph shown here. Density means complexity versus volume or size. Take an example, key value store. Key value store has a high size but low complexity. And column family also has a high size but also low complexity. Compared to all RDBMS document database, column family and key value store, the graph database has very less size but has high complexity in nature. So graph database is a complexity in nature. Trends in big data and NoSQL. Increasing data type. Day by day we are uploading data into the server, so it's normally develops big data. Increasing connected data. Today we are representing all nodes, all networks by using graphs. So day by day networks are increasing. Also increasing connected data increases. It means graph data is expands. Semi-structured data. Semi-structured data is the individualization of data with a common subset, and it's about for distributed application. The property of graph model. First one, core abstraction. Core abstraction has nodes, relationship between nodes and properties on both. Nodes. Commonly, nodes are connected to each other by using links or edges. Relationship between nodes. How they are related to each other. It shows uh, nodes which are how they are connected. Properties on both. Discussing about nodes and relationship between nodes. Traversal framework. High performance queries can connected datasets. neo4j good for highly connected data. Highly connected data are commonly social networks. They are connected to each other. Every node is connected to every another node. So it means highly connected data. Recommendations. neo4j is support for e-commerce networks. Today we are using huge number of e-commerce websites. Pathfinding. How do I know you? Pathfinding means to find the target node by using links. It uses A-star algorithm. A-star algorithm which finds the least distance between target node and searching node. And data first schema, which is takes data and searches for node. That may be bottom up or top down. Some particular operations neo4j is not so good for. They are set operations and enormous amount of data. Set operations. Set operations like union, intersection, cross join. Union means combining of two data paths, and intersections and cross joins are similar to joining. So these operations are problem with neo4j sometimes. Enormous amount of data. neo4j tool support for billion nodes, but it has a problem with the trillion nodes. So more than billion nodes, its problem, it shows problem. A graph example. Here these are nodes. Nodes name are Jonathan, Phil, Mark, and Mary Luke. These are nodes which are connected by links. The relationship is friend. Jonathan is friend with Mark, and similarly Mark friend with Luke. These graphs show both direction of friends. Here above graph diagram, backend it is a code for above diagram. Here creating an object here, create a person name, whatever you want name, give it. It is a object, creating object. Here we are creating objects. Jonathan is equal to create a person, Jonathan. Similarly, all friends are created by objects, Mark, Phil, Mary, Luke. Jonathan, Jonathan and friends are connected by both sides, so both the direction. So Jonathan is connected or friends with both side of Mark. So Mark is friends of Jonathan, Jonathan is friends of Mark. So it shows both direction. Similarly, Mark with Mary, Mark with Phil, Phil with Mary, Phil with Tooth. These four friends are connected by each other. This is some introduction and features of neo4j.
Hello everyone, I am Lingraj. In this video I am going to show how to install neo4j and how to create a node and relationship between the nodes. And to install, go to this website neo4j.com and click on download neo4j. and download this community version. So click on start download. So for downloading it will take some time. So once it will download, you will get the RAR file. So extract here. So this is the folder. So these are the binary files, and these are the library files. And before running this neo4j, you have to install JDK, Java JDK. So go to the Google Chrome and type Java SDK download. So click on the first link and download this JDK. So here you have to accept the license agreement, and based upon the type of OS setting, either Linux or Mac or Solaris or Windows 32-bit or 64-bit, you have to download. So I am using 64-bit. I will download this JDK. So click on start download. So once it is downloaded, we have to install that. So I have already installed it, so I'll pause and cancel it. So here is the JDK file. We have to install it, and place this neo4j.com, sorry, neo4j folder in C drive. So place it in C drive. So here is the folder. Then open that and open these binary files. Before running this batch file, so you may get some errors due to this jar file. So that what we will do, open this base file with text editor, and around the line 57. So here, so initially in some times you have star here, so previous, so that we have to remove that and replace the version of the jar, that is here it is 5, so you have to replace with the version. So I kept here 5, then save it. After that, run this neo4j batch file. So then after that, go to the browser and type localhost colon 7474, enter. So this is the dashboard. Here you will get how many nodes you have created, properties, relationship between the nodes, and relationship types. And in this data browser, you can add the node, relationship, and anything. In console, we can use one of the query language such as CIPHER to create the queries. So go to data browser. So suppose if you want to add a node, so click on node. So I have already created some of the nodes. Suppose if you want to check your nodes, just type the node number 0, then search button. So if you want to add a node, again go here, click on search. Then you can add the properties here. So click on add property, just type and you can specify any name you like, and you can give another property also, like last name, and then you can save it. So you can add how many nodes you like, and just check whether all nodes are present by typing the nodes. So node 1, so node 1 is present, so node 4, so node 4. So here you can see the 8 nodes are created with 7 properties. So I will show the relationship now. So click on the relationship. So from what node to what node you can create the relationship. So suppose I created a new node 6. So I will do from node 4 to node 6. So how it is related? This is the relationship properties. You can specify anything. So now I'll do relationship property as nodes. Then create. So here node 4 knows the node 6. So after that, after creating, then you can create the click on the switch v mode. Just click on the after that here I have added the style. So if you want to add any style, just click on new profile. So just give the style like style name, new style. So you can create either box or circle or icon. So I'll keep it as box, and background of the box you can do it as yellow, and label color as red. Then you can change the font size and this ID, so you can change even the ID, where I'll do it as first name and save. So here you will get the all. So just drag however you like, or just press on relayout, so it will set accordingly. So if you want to edit the style, click on style and click on edit. So we can add another label also, like we have added another property as last name. So we can change the font color, font size, sorry, 12. Click on save. So here you will get the first name and last name, and these are the relationship and nodes. That's it. And these are the style we are giving background color as yellow and font color as red. And this is how we create the nodes and relationship between them. So once you go to dashboard, so here you can see we have created 8 nodes and relationship type is 1. That is we have created only one relationship, that is nodes. So if you want to create another relationship, go to relationship. So from suppose I will create a relationship between node 1 to 4. So with another relation as friend, and click on create. So node 1 is friend to node 4. Then click on switch view graphs. So here we'll get this relationship that John K is friend to John Allison. So go to dashboard. So here we get two relationship type. So this is the how to install and how to create a node and relationship between them.
Introduction to CIPHER. CIPHER is a query language which we used in neo4j. It accesses the query and retrieves. CIPHER is a neo4j graph query language. CIPHER is used in query language for neo4j. CIPHER is a declarative query language. Declarative means whenever you declare, whenever you add nodes, so CIPHER is flexible. You describe what you are interested in. not how it is acquired. So you suppose you are created nodes already created. Suppose you want to change the nodes, so you can change. So CIPHER is supports for any time. CIPHER is meant to be very readable and expressive. Readable means you can read or you can access any nodes at any instant or any time. And expressive means you can change or you can update the nodes or you can add some extra features. So CIPHER is supports for all these above characters. What is a graph? In a graph is a compromise of nodes and relationship. Which compromise of nodes and relationship. Nodes are commonly network links, which networks are connected by links, and that links ends are nodes. A graph database stores data in the graph. So every graph database with nodes and relationships are stores in the graph, which represented by links and nodes. The most generic of data structures capable of elegantly representing any kind of data in a highly accessible way. It it support for different types of data, different type of nodes, and these are in huge form. The records in graph database are called nodes. Nodes are connected to the typed directed relations. So each and every nodes are connected by directed nodes, links, directed links. Each single node and relationship can have named attributes referred to as the properties. Each node has the minimum attributes. A label is the name of that organizes nodes into groups.
Uh, I am going to describe the elements of a graph using basic syntax of CIPHER. So in the previous slide we discussed what is graph, and the graph is composed of nodes and relationship, and the nodes contains the records in graph database are called nodes. So the nodes are connected through the relationship. So we are using this graph concept using CIPHER. So first, how we will describe the nodes in CIPHER. So normally nodes are used to represent entities like actors, directors, and movies. Suppose if we consider a movie database, so the entities like actors, directors, movie, they are represented using nodes. And in CIPHER they are represented using within the open and close parentheses. For example, actors, we give the letters A for actors, so they are represented like this. And movies, they give the M and they are represented within open and close parentheses, and open and close for there is a no node. So here this is a node for actors and this is a node for uh, movie. Next comes a relationship. We know that relationship are used to they are used to connect between one node and another node, and they provide a relationship between the nodes. So they are represented using within the square brackets. And for example, this one. So here R is the relationship, and here R is the relationship. So for example, consider actor A is acted in M. So acted is a relationship between A and M. So you can specify the like you have to give semicolon, sorry, colon, acted in. So where acted in becomes a relationship. So properties. So both nodes and relationship app can have properties. For example, consider nodes with properties. So if we take a node as actor, so it can contain name. So when he was born, these are the properties of an actor. So how many movies he acted. So these are the properties. For example, here A name given as Rajkumar, born in 1945. So actor with name and born property. And the movie also, it is also note it can have the title, movie name or title. So here we have specified the matrix. So this is the node with properties, and we can consider relationship with properties. So if we consider A as acted in movie M, so Then so A acted, so you can specify what is the role played by the actor in that. So I acted in, so I were acted in the relationship, and role is a property for acted in. So he has acted as Raj in the movie M. Labels. So in a database or a graph database, there it contains many nodes. So we have to distinguish from one node to another. Some nodes may be representing the person, some nodes may be representing movie, some nodes can other properties. So we have to give the label for some of the nodes so that we can extract them. So to there also allow us to distinguish between different types of nodes. So any node can have more than one label. So for example, node A actor, so is a person, and here a person with properties, so name, and we specified the label on the top of the node. So property graph, a property graph is a graph which contains the label nodes and the relationship with each properties. So for example, nodes are just data records. So property graph contains label nodes and relationship, and node contains data records and relationship which is used to connect the two nodes. They are also an explicit data record in the graph database. Think of them containing shared information between entities. So properties are simple. So key colon value pairs. So this is an example. Here are three nodes A, B, C, and A is labeled as a person with a property name is Rajkumar, and A knows B. So this is a relationship. So it has a property since 2003, and B is another node which is labeled as person with a property name, and here B is as a relationship with C directed. So C is having the label movie. So now I'm going to talk about the cipher clauses. So first cipher clause is match and where. So match and where means it matches the given query and returns the nodes which are present. So it finds a pattern and filtering out the result with predicates where. So for example, consider match node M to N where M is not empty node. So M is not linked to any empty node. So return N. So for that, to execute this query, go to Google Chrome, and here click on console. So write that query. And in the final give colon and press enter. So it will give all the nodes. So node 4 which we have created in the dashboard, sorry, data browser. Okay, there it give all the nodes. And next is create. So this is used to create the new nodes. And so for example here just create n foo b. So here it creates two nodes n and b. So here b has a relationship bar, so sorry, b has a property bar, and n is related to bar with foo. So then we are returning both n and b. So so let us execute this. Now click enter. So two nodes are created, node n, b, and it is not all on 13, and one row nodes created 2, so that is n and b. Relationship is created 1, that is foo, and labels added 1, so that is b. B is adding the label n. So next I will go to return. So this is going to return whatever you specify in the query. So used to return the nodes relationship that we specified in the query. So for this, execute this, go here. So click enter. So it will create, it give all the nodes which are present, and having the, so which are connected to an this non-empty node. So next is CIPHER aggregation functions. So CIPHER has some built-in aggregate functions like count, sum, average, minimum, and more. So in this I will take count, so which will return the number of outbound relationship from each node. So here it will give all the nodes. It has node 8 as one relationship, node 2 it has one relationship, and is all, it specifies all this. Then this is all about the CIPHER language, and all the aggregate functions and all about the CIPHER classes, and how we represent the nodes representations and everything in CIPHER. Thank you.